Welcome to the BA webinar series. We are excited you could join us today for Jen Stirrup's session on catching the butterfly in data, chaos or patterns in the data. My name is Vicki Van Dam, Project and Operations Manager for PASS HQ. I have a few quick introduction slides before I hand the reins over to Jen. Jen is an author, data scientist, technical community advocate, and the director of Data Relish. Jen is also a SQL Server MVP and a business intelligence and data visualization expert. As one of the top 100 most global influential tweeters, Jen is also a prominent figure in the business analytics and business intelligence community. She has been recognized by the PASS community with the prestigious Passion Award in 2012 and is currently serving as a director on the PASS board. At the PASS Business Analytics Conference in April, Jen will also be presenting her session, Pulling Back the Green Curtain, Data Forensics, Power BI, and Data Viz. If you want to connect with Jen, or if you have any questions after watching this webinar, you can contact her via email, on Facebook, and through Twitter or LinkedIn. You can also check out her blog and YouTube channel. The PASS BA conference is on April 20th to 22nd this year in Santa Clara. The conference is designed to follow the analyst's journey from sessions covering the discovery and integration of data to analyzing and interpreting data and communicating insights throughout your business. Along the journey, you'll gain the critical business and data analytics skills that you need today to stay ahead of the curve. Industry experts and professionals will show you how to use technology to uncover insights and deliver new value to your organization. The unique design of the conference gives you practical and indispensable knowledge you can use immediately. Without any further ado, I will hand things over to Jen. Take it away.
Hello everybody, and thank you very much Vicki, and thank you for everyone at PASS for looking after me today. Now what I'd like to talk about, something I'm very passionate about, which is data, because I believe that it's the time where data analysts and business analysts are cool, finally. We are much valued, I think, in organisations because we tell the stories of the data and we tell the truth of organisations of what's actually happening. And the reason that we do that is because we have the data, we have the information, and we have the facts at our fingertips. Now, in order to get these insights, we need to be able to analyse, produce, and see the patterns in data. I love data, I think, because it's a really creative problem-solving process. So the thing is, as much as it's an exciting process to look at data and find results, sometimes people don't do the homework when they're evaluating the data in the first place. So we have a quote from Terry Pratchett here saying that he'll be more enthusiastic about encouraging thinking outside of the box when there's evidence of any thinking going on inside it. And sometimes I feel that organisations have a bit of a Schrodinger's cat approach to their data, and by that I mean they tend to think if we don't look at it too closely it might be all right. But the thing is, we're going towards a data culture where data is becoming so important in organisations that we can't think like that anymore. So what kind of analyses do we actually do on our data? Well, first of all, in business intelligence, we normally look at descriptive data. What is happening in a given situation right now? What's the last thing that happened when the data warehouse was updated, and what's the latest data that I have? So that's very much about business intelligence and descriptive statistics. What happened, who did what, and how did that happen? However, when we move into business analytics, we can springboard to business analytics from business intelligence. We can start to do diagnostic tests on our data and working out what are the key drivers in making something happen. That can be clustering and classifying data, such as clustering and segmenting our customers into groups. And that gives us a business question, why? Why did this happen? How can we tell? And then when we understand more about the why, then we can start to predict using our data. So we can start to see what will happen next. We can predict an outcome and what the likelihood is of a certain outcome. Finally, we reach the holy grail of analytics, which is prescriptive. What should I do? Suggest a course of action to me. Find me the best customers, for example. Find me those people that have the propensity to respond to a particular marketing offer. So there the data is really helping to give you advice. So how can chaos be applied to data? Well, first of all, what is chaos? Chaos theory systems tend to look quite disordered. They may just look like a random set of numbers. But it's all about finding the underlying order in what appears to be very random data. Chaos is not disorder, they're not the same thing. Chaos is the transition between order and disorder. And we have order and disorder in our data all the time. Now, what is the butterfly effect? Well, it's the example that they give, it was coined by Lorenz, who said that the flapping of a single butterfly's wing today produces a tiny change in the state of the atmosphere. Over a period of time, what the atmosphere does actually diverges from what it would have done. So, for example, the theory goes that in a month's time, a tornado would have devastated the Indonesian coast. That doesn't happen. And maybe one that wasn't going to happen actually does. So there's more about that in Ian Stewart's book, Does God Play Dice? The Mathematics of Chaos. But the main point of the butterfly effect is that it's very sensitive dependence on the initial conditions in the data. It's a tiny state in the atmosphere which ripples through and has a huge effect. So the amount of difference in the starting points of two curves of data is so small, but it can have a huge impact. An example of that might be weather prediction, for example. So what you need to do is know your variables and inputs. Now that's all about understanding the data, understanding the quality of the data. Lots of people don't seem to look at the data in really great detail to look for those edge cases, those outliers, the things that tell you that something is wrong in that data. The way that we can do that is by using data visualization in order to understand the data, or we can use it to analyze the data as well. Because sometimes things just don't seem to add up properly. So, for example, some results in the data might not show that x and y equals z, for example. For example, if you look at something like quantum mechanics, it would predict that a given system is the sum of its parts and should behave as x or y. But chaos says that some results don't actually show this. For example, the correspondence between classical mechanics and quantum mechanics and chaotic systems don't always show that x and y equals z. Examples of that might be to do with the ionization rates of atoms, for example. And medical studies of epilepsy also can show the effects of chaos. They can show this effect as well. So it's not always quite as simple as in BI, where we say A plus B equals C. Sometimes there are things going on in the data which makes us realise that actually it's not as simple as that, and something somewhere is having a huge effect on the rest of the data. We are trained as human beings to look for patterns. We look for patterns all of the time. So if we look at the left-hand side picture here, this is a picture of the island of St Kilda, which is off the west coast of Scotland, where I'm from. And what it seems to look like a human face. And that's on the left-hand side. On the right-hand side, what we see here is that it looks, first of all, like a face. But what we actually realise that the face is actually food. Now that's a picture by Giuseppe Arcimboldo, and it's called The Jurist. And what he's done there is it just simply illustrates that we look for patterns all the time. And the patterns jump out at us, even if the actual data don't always make any sense. Patternicity tended to be seen as an error in cognition. So, for example, sometimes people believe they can see religious figures in a slice of toast, or UFOologists might see a face on Mars, or they might see religious figures on the side of a building. And the reason for that is we just simply are looking for patterns all the time. So a type 1 error would be a false positive where there is a pattern, where there isn't a pattern but actually we think that there is one. And then we get a type 2 error as well, which is a false negative where we don't believe something is real when it isn't. That's called apatternicity. So our brains have belief systems, and we have a belief heuristics that connects data together and creates meaning from that data. There's an environmental benefit to believing which patterns are real and which ones are not. So we're constantly evaluating patterns through data visualization all of the time. So how can you tame the chaos in your data? What you have to realise is that changes in the data are part of the data storytelling. That's something that happens in the data all of the time. It allows you to move towards that holy grail of analysis, where we're moving towards prescriptive analysis, where people try to predict and control variables in order to understand what's going to happen next. Business intelligence tells us all about what's happening up to this point. But then we want to move forward and try to predict the next step. At that point, it's very important to control the variables and listen to feedback in the system as well. We also want to visualize the data so that something jumps out back at us. We also want to analyze the data as well. It's always important to have the context of the data too. For example, statistics might show there's a 90% chance that your son is expecting a baby, but that's actually, you know from the context, that simply can't be true. It's all about checking, checking, and checking again, looking at that context. Okay, so we've got some examples in the public domain where we talk about predicting data. We're trying to understand what's happening next. Now, something that's quite a hot topic in Europe in the moment is government debt. And there's lots of data about government debt, and there's lots of data storytelling that we can do with this. For example, Japan, the government debt as a percentage of GDP is 245%. For Greece, it's 174%. Italy is 137, which is quite close to Portugal. Portugal is 131. So what we can see here is the UK is 92%, it's not too bad, but we've had quite a period of what you might call austerity over here, and we're trying to make sure that we are trying to be as fiscally prudent as possible. And we've got also China as well, 41%, and the Ukraine at 68%. So the interesting thing is that a lot of European countries are at very close to danger levels. So how do we actually calculate public debt? Well, there's a number of variables involved in this. So, for example, it's key macroeconomic variables, the real GDP growth. Growth is actually quite difficult to predict, as you might imagine. We've also got the effective real interest rate as well, the balance, the change in the real exchange rate, as well as the share of public debt in foreign currency. So we also look at things like economic growth, we look at borrowing costs as well, and how well the country is actually tightening its belt and not spending too much. But it's not a very easy thing to do. So how do we know if a country is bankrupt? Well, it seems to be that this is a problem which doesn't really seem to go away. You might have heard of the Scottish economist and philosopher Adam Smith, who founded modern capitalism with his book The Wealth of Nations, which was written in 1776. And what he said was, when national debts have once been accumulated to a certain degree, there is scarce, I believe, a single instance of their having been fairly and completely paid. So when you do some research, there's actually very few instances of it being paid back completely, totally and fully. In the Ceausescu regime in Romania, they had a very stringent policy of paying back all of the foreign debt, but that meant they had to close factories at certain times of the day in order to save electricity, and they also switched the electricity off at night for people as well. So how to work out if a country is bankrupt or not is actually very difficult. So here we've got an example here. We've got the advanced economies, and we've got the world economy in yellow, and we've got Latin America and the Caribbean in blue. The emerging and developing Asia are in light grey. So what you find is actually that the gross public debt as a percentage of GDP seems to be higher for advanced economies, much higher than it is in the world. And that might be a surprise to find that that is the case. So debts on their own can be a bit misleading. So private debts can become public liabilities, for example. We might end up in the situation that we've seen in Ireland and in Spain, where very bloated banking sectors actually implode. And what happens then is, although it was a private debt, it becomes a public liability because the government becomes involved and they have to bail them out. And there's usually an outcry at this point. There's an outcry if the government doesn't bail them out, and there's an outcry if the government does bail them out. So they can't actually win. So the structure of debt itself is actually very important. For example, a short-term debt is to be cleared, but that can also present a risk if it's not. So let's have a quick look at some data. Now I'm just going to show you Power BI. And what we have here is I've loaded in some data from the International Monetary Fund. And when you do that, what you can do is we've got Power Query here. And we've got workbook queries on the right-hand side. So what I've got here is some errors when I loaded in the data, and those have just been, the load for those is disabled. It turned out that the data was a bit messy and had a lot of blanks in it, so I'll just get rid of those. So the query that I actually have in place just now, we can see that in Power Query. What I've actually done is I've taken the data and I've unpivoted the tables, so that's the end result. I'm just going to close that. And what we see here is this is the original observation data, which I took from the International Monetary Fund. So what we can do is I've just taken a straight download. We can see that the data itself is all decimal points. There's a few blanks in here. For example, there's no data for South Sudan. There's also a lot of repetitious data as well. So if we take all of this data, how can we start to clean it up? Well, that's what Power Query is for. So what I'm going to do is highlight this data, and then I'm going to go to the Power Query tab here, and then I'm going to do From Table. So first of all, let's get rid of the items that we don't need. So when we right-click in the column, we can simply remove it. I don't need the ISO 2 code for each of the countries, so we'll get rid of that. I won't bother with the regional idea either. Now, if we filter, we see that the subject is fairly redundant. We've got this here, which is the IMF's code for the data. So I'm just going to remove that column too because I don't need it. So the subject name, this tells us that we're looking at the general government's net debt as a percentage of GDP. So what we have here is that's the only option. It's not giving us anything, so I'm just going to remove these columns as well. So we don't need the descriptor, the notes, the scale, or the units. So I'll just get rid of all of those. So that leaves us with the data in this column. Now at first glance that probably looks quite tidy, but the problem is that data like this is very difficult to visualize properly. When we look at doing visualizations across years, what we want to do is do something like a time series or a timeline. We want to do line charts. We want to do something which shows continuous data. But when we do this, it will come up as a bar chart. And we like the idea of having a nice flow of the data as we move throughout the years. So what I'm going to do is unpivot these columns. So I'm going to click them all, go to Transform, and there's an option here to unpivot columns. I could unpivot the other columns, but that wouldn't make sense. So let's just pivot those ones. Then all I need to do is rename this. I'm going to rename that to year. Now this value, I'm just going to call that percentage, so that's easily, so that's debt to GDP percent. Now I'm just going to check the data types, because that says it's a percent, but here what we have is the data type is coming up as any, and what happens there is if the data type comes up as any, then Excel is going to see that as a piece of text. It's not going to see it as a number, so when we go to visualize the data, it's not going to make any sense because it wouldn't have any numbers to visualize. It wouldn't allow you to produce a sensible chart. So what we're going to do is make that decimal number. Yeah. So I'm just going to call this debt to GDP demo. I've got all my steps here on the right hand side, and if I want to remove those I just click the cross at the left hand side, but I do want to keep them. So what I'm going to do now is close and load the data, and I'm going to load that to the data model as well. Right, I'm just going to check the data types as well. It's came up as general, but we want that to be a number. So off it goes. So I'm just going to check the underlying data model. So Power Pivot here, also known as Excel data model, we click on Manage and we can see the data in here. Now fortunately the data type has came through as a decimal and that's come through as general. So that looks fine. So we're happy with that. And then this is the one that we've just done, which is country and year, and then that's a renamed column which is debt to GDP percent. That's come through as decimal number, it's come through as general, so we're happy with that one. And this is the one we're going to use for the demo. This is the data we've just imported. So I'm just going to close that. So now I want to visualize the data. Now here's an example I did earlier. It's very, very simple to do. All we do is go to Power View. In fact, all we do is go to Insert, and then all we need to do is go to Power View. And I'm going to give this the same title as the underlined sheet. So that's debt to GDP as percentage. Okay. So what I've got here is we can see a preview of our data, and all we need to do is add it. So I'll go to the demo here. Now it's important to note here we've got the country name. It comes up with a geographical symbol next to it, so that's how we know it's going to be recognised as geography. And then we're going to see debts to GDP percent. We want that. Now it's aggregated it because we haven't collected years in as well. So that gives us the actual granular data, and that's what we want to see. Now it looks a bit odd because we see country here, then we see the value, then we see the year. So what we want to do is create the year, and that's our data. Now we could present our data in a table, and it would probably look fine as a table. But the problem that we have with this is that it won't look so good as a table. We don't see the patterns in the data. So what we actually want to do is create a visualization with it. So with this one, we're going to create a line chart. Just really simple. Now there's too many country name values here, and that's correct. We see the overall pattern of the data, but it doesn't make any sense because it's all dots. It looks like a timeline, but we've actually got countries and the axes here, and what we should do is have years. So I'm just going to take year from the right hand side, and I'm going to put that in the axis. So we've got some dots here. So this again is just aggregating all of the results. But what I want to do is filter by country name as well. Now it's got legends being the year, and actually prefer legends to be the country. So that's really messy. That gives us a lot of data. Wow, that looks interesting. Liberia has got the debt to GDP percentage as being 694%. Wow. So what I'd want to do there is start to look at the data. So why don't we visualize this data? Again, it still looks very confusing for us to look at. We can see the purple line here is Libya. debt to GDP percentage is coming up as the lowest. And here we've got Finland. Finland's doing extremely well. So let's take some examples in the data. So what I want to do, I want to just take Greece. You can see there's a large spike there. There's a small projection here between 2014 and 2015. The IMF have got projected figures, and the projected figures have came across. And what we have here is Germany. So we can see Germany much more static, hello, down there. Then we've got Ireland as well. So what we see is that in Ireland, as their economy increases, we see that they have larger problems here. So what we can start to do is have a think about where poor Ireland is going, because their data suggests quite a big rise in that debt to GDP percentage. What we have as well is we also will look at Liberia. So you can see what's happens there. Now all of a sudden bidding in Liberia, because it's an outlier up here, the rest of the data just goes straight down, and you can't see the patterns quite as much. Again, if we add Libya as well, we start to lose some of the patterns in the middle almost. So we'll take those two out. So we also said about Spain. Spain also inherited a lot of private debt, which was being paid off as public liability. So again, we can see the patterns, just at a glance, look much more closer to Ireland than you would expect. So what we can do, we could create a scatter chart with this data as well. And then if we put year and the play axis down here, we can start to make our data move a little bit. So the debt to GDP percent doesn't look very clear there. What we have to do, the Y value has to come across as being the year. And we'll make debt to GDP percent go here as well. We'll put that back, and then we'll put the Y value down here as well. Now the reason it doesn't want the Y value here is because it has to be an integer. So the only other integer I've got is here, so that will do. And we'll make the size go here as well. So what we can see straight away is that Germany has got the lowest, Spain, Ireland and Greece has got the largest. Now the area is actually representing the value here. And what we could do then is start to have a look at playing that data. So we see over time, Greece ends up still with the highest there. So what I'm going to do now is we've just had a very small look. Now this is called a motion chart. We've had a quick look at how we can look at patterns in the data through visualizing it. But what I'd like to do is we'll have a quick look at some of the stats that can help us to identify patterns as well. There we go. Alright, so now we have something in statistics which is called Benford's law, and what it is a way of looking for patterns in the data. It's a very, very intuitive way of spotting whether data is dodgy or not. So what Benford's law actually does is it proposes a distribution for the first digits of numbers in naturally occurring data. So for example, in the European Union, there's pressure for countries to comply with the Stability and the Growth Pact criteria. So for example, like firms, in order to join the European Union, there's certainly an incentive for governments to try and make their economic situation appear a little better than it is. So for example, some researchers have used Benford's law as a way of investigating the quality of the macroeconomic data, which is relevant to the deficit criteria reported to Eurostat by the EU member states. The researchers found that the data reported by Greece shows the greatest deviation from Benford's law across all European states. So the examination of the quarterly GDP growth rate showed that the zero occurred as a second digit 21 times, which is much higher than what the Benford's law would calculate, and suggesting a rounding up to achieve a bigger leading digit. So what we tend to find is, how robust is that? Well, when we look at the Chinese data, there did seem to be that rounding up, but we're not suggesting that there's any fraud involved there. That could be a cultural thing there, for example. So what actually is Benford's law? Well, in many real-life sources of data, the leading digit is distributed in a very specific non-uniform way. So the first digit is number 1, and it occurs about 30% of the time. Larger digits occur with lower and lower frequency, so we go from 30% at the time when the first leading digit is 1, down to 5% where the number 9 occurs less than 5% in the very first space. So the timeline is that Simon Newcomb found this information simply by looking up his logarithm book. He realised that the logarithm leaflet was actually much better thumbed where the first digit was a 1 than when it was a 9. So he started to take an interest in the location of numbers. So Benford's law is also known as the first digit law. It says that in lists of numbers from many but not all real-life sources of data, the leading digit is, according to the law, the first digit is 1 about 30% of the time. So that's Wikipedia, you can go and look that up. So then more recently, Dr. Mark Negrini showed a thesis noting that Benford's law could be used to detect fraud in financial data, that human choices are not random, and that invented or made up numbers are unlikely to follow Benford's law. So what kind of data types might fit Benford's law? Well, what we see is that transactions might do it, accountancy data, stock prices, purchase orders, and travel expenses. So not all data types conform, for example. So telephones numbers don't conform because they're not natural numbers, they're more descriptive. People's heights don't conform either in inches or in centimetres. So because normally people are something between like 100 and 199 centimetres tall as adults. So that means you don't get people who are maybe 200 centimetres tall or 300 centimetres tall, for example. Heights are very specific in one range. So prices where there's a threshold or a cap, it doesn't apply to aggregated data or data where there's not enough transactions. So examples might be data audits. You can check the data. When you audit data, you could use Benford's law just to have a look to see if any numbers look a bit strange. You could use outliers, the way that the data was acquired, look for missing data, system information, and event timings as well. The event timings might look a bit odd. So we can look for strange behaviours in the process as well, bypassing permission limits. So something that can happen in the data is a bit like the wings of the butterfly beating. It just gives a very small effect initially, but it soon rattles its way throughout the data, and that's where you catch it. So what we'll do is we have occurrences in example European data. So what we have here is the overall deficit surplus. And what we've got here is the number of times that number 1 appears to be in the very first space of the data. The number 2 appears a little less likely at 17%. Number 3 appears less likely again. And what we have here is Benford's law, where Benford says that the number 1 is likely to appear in the very first slot 30% of the time. Number 2 is likely to appear in the first slot 18% of the time. So it was quite difficult to tell from this little table what the patterns look like. But what we see when we look at the European data is that the overall deficit surplus does actually follow Benford's law reasonably closely when we look at the visualization. So Benford's law, the actual statistical prediction, is outlined by the orange number here, and the blue bar charts actually give you the actual occurrence. So what we have here is that the actual, the blue lines, are fairly close to the expected numbers. We can also visualize this in Power BI as well. So what we've done here is the same thing, but we've done it in a line chart. We've got the occurrence, the actual, versus the expected, which is Benford's law. So we see that for the overall data, it looks like Benford's law could be holding there. We could do further analysis to see how well it actually holds up, and obviously more data as well. So Benford's law, for example, is absolutely not the final word, but it is a start for the curious if you want to start looking at your data. And you have to doubt yourself all the time, prove everything, and think repeatable principles in science, repeating your data. So, for example, if you give your data to someone else, are they going to catch the butterfly in your data? Are they going to be able to find this small piece of data that was having quite a large effect somewhere? And the context is vital. The data itself is actually feeling meaningless without it. It's about trying to find out why things are happening the way that they are. So when we look at the country data, what we can see is that there are stories for each of those countries and how they got there, but presumably, like the quote from Adam Smith, they started off in the same place, but diverged quite widely. So what we have, just to summarise, is that we can use a mixture of statistics and visualisation in order to really understand our data, because data at the first glance can look like chaos, but there's patterns in there, and those patterns are what we're trying to identify. So just to wrap up, back to PASS, I'd like to thank PASS for hosting the session today. We have the PASS virtual chapters for business analytics, and I really recommend that you listen to the virtual chapters. They are obviously open all the time, and they're basically a series of webinars. They're hosted by the community. They offer high quality educational, technical and business analytic content geared towards the whole community. So we have business analytics as a virtual chapter. We have one which focuses more in analytics and Excel. We have the business intelligence chapter. We also have big data and the cloud one as well, if you need to analyse lots and lots of data, which sounds more fun than anything else, I think. And if you are looking for a business analytics conference, we have the PASS Business Analytics Conference, which is taking place in April 20th to the 22nd, and that's in Santa Clara, California. I'm hoping very, very much that I'll see you there. I'm really, really excited to be part of the conference, and I can't wait. It's got some great speakers, and I cannot wait to see everybody there. If you want to see our list of speakers, go to passbaconference.com. We have lots of people from the Excel world, so we have Rob Colley, we have Chandu coming as well, who will help make you awesome in Excel. And we also have leaders in analytic fields, so for example, we've got James Cabelius coming from IBM to talk big data to us. And we also have Richard Lee as well, who's going to talk about the data leadership nexus. So if data is your thing, like it is mine, I really recommend you come and join us. Join us to meet other data professionals who are as interested in data as you are. So with that, I just wanted to say thank you to PASS for hosting the session, and also thank you to you for listening. And with that, I'll hand back over to the team at PASS HQ, and I will bid you good evening, good afternoon, or good morning, wherever you happen to be in the world.
Thanks so much, Jen, for a great session. And as she said, if you're interested in joining us at the PASS BA conference, April 20th to 22nd, visit us at